disaster preparedness aspect is very crucial for any nation, as various types of disaster occurrences can be forecasted to a near level of accuracy, which can be acted upon. It is quite difficult to predict a very few types of disasters as they strike suddenly, but in practice it is generally observed that many of the nations quite often are not geared up to disaster preparedness, though it being a recurrent event. The occurrence of disasters cannot be fully stopped, but the devastation caused by the disasters can definitely be averted, mitigated to a larger extent by paying attention to the early warning systems sounded out by nature and also by usage of technology backed alerts by the practicing experts in this area. As the proverb goes, a stitch in time saves 9. So does, by paying attention to early warning signals, the effects of calamities can be deftly managed by mitigating the extent of damage levels. Early warning systems have gained momentum and are nowadays prominently considered to be the core component of comprehensive disaster preparedness plans and also involve a broader spectrum of stakeholders. Early warning systems (EWS) is defined as a process which looks at putting together the capacities needed for the generation and dissemination of the much reliable and timely information as a warning to be acted upon by the communities organizations for the possible occurrence of the disasters. Simply put, the early warning systems are the ways by which people will receive the relevant and real time information in a systematic manner at pre-designated intervals, usually in the form of alerts and bulletins prior to the occurrence of the disaster, in order to make informed decisions in facilitating actions. The early warning systems is essentially an interplay among an array of elements which aims at facilitating communication to initiate prompt response to protect and aid those in need. An effective early warning systems has to possess the following characteristics: based on sound and scientific technical know-how, people-centered, clear delivery systems with simple communication, multi-sector coordination and pertinent to the communities to which it is intended. Existing ones can still be made better. The way to improve effectiveness can be undertaken by critical analysis to determine what early warning can realistically achieve and what is outside its purview. It is in this context, let us examine the early warning systems which can be helpful in tackling the disasters and also in devising the models of disaster preparedness, its advantages and limitations. The following 4 basic elements are essential to an early warning system to function efficiently. Knowledge of risks enables one to the baseline understanding about risks, hazards and vulnerabilities and priorities at a given level. Monitoring is the follow-up activity to keep abreast on how those risks and vulnerabilities play over the time periods. Response capability aims at reducing risk once trends are spotted and announced through pre-season mitigation activities, evacuation or duck and cover reflexes depending on the lead time of a warning. Communication sends the monitoring information into actionable modes to understood by those that need and are prepared to hear it. Elements of early warning system. The following 4 are the elements of early warning systems. 1. Risk knowledge, which includes hazard, elements at risk and vulnerabilities. 2. Monitoring and warning, rainfall, river level, warning decision. 3. Dissemination and communication, radio (TV), telephone, household warning. Response capability, evacuation center, search and rescue, relief goods. In the Indian context, the various agencies responsible for forecasting of the early warnings are illustrated in the following table. Agencies for forecasting: Cyclone, Indian Meteorological Department; Tsunami, Indian National Center for Oceanic Information Services; Floods, Central Water Commission; Earthquakes, Indian Meteorological Department. Early warning systems. The early warning systems differ based on the nature of the disaster. Let us note few early warning systems for the following commonly occurring disasters: cyclones, flooding, landslides, earthquakes, tsunami, drought. Cyclone forecasting. The cyclones are the most common disasters to occur more frequently. The low pressure systems which are developed over the warm sea are called as tropical cyclones (TC). In the Indian context, the occurrence of TC is a common phenomenon in Bay of Bengal than in Arabian Sea. These TC have the potential to cause heavy damage due to furious winds, incessant torrential rains and high storm surges. Indian Meteorological Department IMD is designated to monitor and give warnings regarding tropical cyclone. Detection of the harmful event and getting people out of the way of such an harmful event is the beginning point of any warning system. Such a warning systems encompass equally important elements of detection and warning, communication and response. These will be in the form of the pre-cyclone watch and the post-landfall scenario in case of cyclone forecasting, which meets the requirements of government non-government agencies of administration and crisis managers for undertaking interventions. The cyclone warning is done in the following stages: pre-cyclone watch, cyclone alert stage, cyclone warning, post landfall scenario stage. Pre-cyclone watch stage. In this stage, a monsoon depression having the potential to hit the coast and itself developing into a cyclone disturbance is warned about. The coastal stretch likely to be affected is identified. This early warning bulletin is issued by the IMD before the cyclone alert stage, which provides sufficient lead time for the crisis managers to undertake disaster preparedness action. If any coastal belt is expected to experience adverse weather in the form of heavy rains, gales, tidal waves in association with a cyclonic storm or a depression, the district collectors of coastal and adjoining districts and the chief secretary of the concerned maritime state are informed and alerted. Cyclone alert stage. The cyclone alert is sounded 48 hours in advance of the anticipated onset of adverse weather conditions over the coastal areas, with forecasts regarding the commencement of the strong winds, heavy downpour along the coast in association with arrival of cyclone. At this stage, the landfall point is usually not identified. Cyclone warning stage. The cyclone warning is considered as the third stage of warning and is issued 24 hours well in advance. Landfall point forecast is done in this stage of cyclone warning. The forecast for heavy rains coupled with strong winds and the storm surge is also issued. This information is crucial for taking follow-up action for evacuation of people and cattle from the low-lying areas, as storm surge is the biggest killer so far as the devastating attributes of a storm are concerned. In this fourth stage, known as post-landfall scenario stage, landfall point is now identified, usually as a part of the cyclone warning stage, either at the time of landfall of the disturbance or about 12 hours in advance of it. It includes warnings of strong winds and heavy rains likely to be encountered in the interior districts. The forecasting and monitoring processes have been revolutionized and continuously upgraded by the deployment of state-of-the-art remote sensing techniques and satellite-based observations and radar systems. Installation of the satellite integrated automated weather stations on islands, oil rigs and high altitudes, vulnerable locations along coastal sites will aid in providing much needed meteorological and oceanographic data. Indian Meteorological Department IMD also utilizes VSAT technology. In addition, there are a number of HF/RT and VHF links. Cyclone warnings are communicated to crisis managers and other concerned organizations by high priority internet, fixed line and wireless telephones, mobile phones and police wireless. IMD is in the forefront of issuing cyclone warnings from the area cyclone warning centers, that is ACWCs, and cyclone warning centers CWCs, which are spread in various parts of the country. In addition to the above mentioned systems, there is also a satellite based communication system called the Cyclone Warning Dissemination Systems CWDS for transmission of warnings. The general public, seafarers, the Coast Guard, cruise operators, the coastal residents and fishermen are also warned through the government machinery and public address systems, broadcast of warnings through AIR, All India Radio and television bulletins, special control rooms. Flood forecasting. Though the duration of the monsoon season is very short in India from June to September, on account of heavy spells of downpour, the rivers will generally be in spate during these months, owing to the inadequate capacity of the river banks to hold such heavy inflows rushing down from the upper catchment areas due to heavy rainfall leads to flooding. It is also caused by accumulation of water resulting from heavy spells of precipitation over areas which have got very poor drainage characteristics. In urban areas, the inundation of areas usually happen as the drains and other water discharge channels, sewerage systems are encroached upon. They are converted into level land by landfills, turning them into residential areas. In urban areas, the rivers have almost disappeared and their path is almost non-existent, and if any, many of them are rendered to carry sewerage disposal. This is leading to waterlogging in low-lying areas, causing urban flooding. As the water does not have a proper path for efficient discharge, it flows onto the houses in urban areas, causing mudsludge and heavy loss to vehicles and consumer durables. The flooding is also accentuated by the erosion and silting, leading to meandering of the rivers in the plains and associated areas, leading to reduction in the carrying capacity of the river channels. Earthquakes and landslides and cloudbursts also contribute to flood situation, leading to changes in river course by altering its natural course, resulting in the creating of obstructions to free flow of water. Synchronization of floods in the main rivers, rivulets and tributaries with retardation of flow due to tidal effects causes major floods. The basic objective of flood early warning systems is to issue the forecasts and warnings well in advance for enabling the likely damage centers of the actual arrival of floods, so that the people can move, and also to remove the movable property to safer places or to high altitude platforms which are specially designed and constructed for meeting such eventualities. The flood forecasting process comprises of the following three main steps: observation and gathering of data related to hydrological and hydrometeorological aspects, the onward transmission of data to forecasting centers for analysis, the formulation of forecast and forecast dissemination. The forecast is considered to be accurate if forecast water level is within plus minus 15 centimeters of actual water level of the inflow forecast, that is discharge, is within plus or minus 20% of actual discharge. Low flood stage. In this level of flood stage, the water level of the river flows between the warning level and the danger level of the forecasting stations. Medium flood stage. The river water level is at or above the danger level, but below 0.50 of its highest flood level HFL of the forecasting station. High flood stage. If the forecasting station's river water level is below the HFL, but within 0.50 meters of the HFL. Unprecedented flood stage. Unprecedented floods occur when the river at any forecasting station attains water level equal to or above its previous HFL. Special yellow bulletins are issued at high flood stage. Red bulletins highlighting security of the problem are also issued at unprecedented flood stage. Based on the flood stage concerned, colored flags are also flown in the river area as danger levels 1, 2, 3. Based on the reservoir water levels and the inflows, the dam gates will be opened for discharge of excess water into the main canals and sometimes into the sea for ensuring the safety of the dams. When such excess water is released into the lower areas of the dams, the people inhabiting in such areas are alerted through public address systems in advance, and also sirens are blown to alert the people. Landslides. Landslides can occur quickly, often with little notice. The best way to prepare is to stay informed about changes in and around your home that could signal that a landslide is likely to occur. Here are some warning signs to look for landslides, which are based on the latest instrumentation and also the empirical link between precipitation, ground saturation and displacement. The warning systems are based on space related technology, which issues alerts by tracking changes taking place in the geographical terrain, ranging from ecosystem, cropping patterns to rock formations, which helps in dividing the terrain for landslides into the hazard zones of high, semi and low intensity. The changes taking place in the landscape, such as flow pattern of stormwater drainage on slopes, occurrence of land movement, minor slides and flows or progressively leaning trees, tilting of fencing structures, retaining walls, utility poles or trees, appearance of new cracks in plaster, tiles, brick or foundations of the constructions, outside walls, walks or stairs being pulling away from the building, appearance of slowly developing deep widening cracks on the ground or on paved areas, breaking of underground utility pipe and cable lines, seepage of water through new locations on the ground surfaces. A rumbling sound which is faint initially but increases in volume is audible as the landslide nears. The ground slopes tilting downward in one direction and may begin shifting in that direction under your feet. Unusual sounds such as cracking of trees or knocking of boulders together might indicate moving debris. Collapsed and damaged pavements, loose soil and mud, fallen boulders and rocks and other indications of possible debris flow can be seen while driving. The embankments which are along the roadsides are more susceptible to landslides. Earthquakes. Real-time earthquake seismic information is provided by Earthquake Early Warning EEW system. EEW system is embedded with the potential to issue warning prior to significant ground shaking. This is made possible by precisely detecting the radiating energy from the P and S waves. This happens due to shifting and collision of the tectonic plates from an earthquake friction in the deeper interiors of the earth. By estimating the ground shaking, it is presumed earthquake will hit later in time either at the same location or some other location based on the earthquake engineering. As the lead time is very short, EEW is based on the distance from the epicenter, which can give few seconds to minutes of warning, which can be alerted by blowing of sirens. Tsunami. The tsunami alert is based on earthquake early warning system and is predicted with higher accuracy. The lead times are more higher in these cases, which ranges from a few minutes to 7 hours. Tsunami Early Warning Center generally has a data warehouse of information related to ocean observation, atmospheric sciences and marine data. This data is transmitted to a host of users like fishing community, seaports and harbors, shipping industry, liners, navy, coast guards, NHO, Central Pollution Control Board. For issuing a warning, the early warning system uses the data received from various centers like the seismic stations, sea level gauges, bottom pressure recorders, tsunami buoys and the numerical models will aid to predict the water level changes which are expected at different locations along the coast is used to issue early warning so that evacuation and rescue efforts can be put in place. Drought. Drought is a complex disaster and differs from other natural hazards in various aspects. It is essentially a hydrometeorological disaster which is a regional phenomenon highly concentrated in nature, whose characteristics will vary significantly among different regions. There is a great difficulty in clearly demarcating the onset and end of drought, as the effects of drought will be lasting for a quite considerable period of time. Drought is a critical phenomenon of climatic change whose occurrence, duration, intensity and spatial extent is difficult to quantify. According to Ray 2000, few of the lead indicators for identifying the drought hazard are analysis of rainfall, temperature and soil moisture measurements from meteorological stations, Vigueria and Vicente Serrano 2006. When there is a prolonged period of dry spell occurring with little or no rain in an area, it can be predicted that the area is going to face drought. The drought early warning system exists in the country to monitor the behavior of agroclimatic indicators like rainfall percentages, arid conditions, acreage, temperature, water level in reservoirs and crop conditions on a weekly basis from June to September, that is Kharif season, which is essentially a multi-institutional initiative. This early warning system, called the Crop Weather Watch Group, facilitates intervention of the government in July-August itself, rather than waiting for a damage assessment at the end of the cropping season, that is October to November. Types of drought. Meteorological drought indicates the actual deficiency of rainfall in comparison to normal rainfall in a given region. Hydrological drought indicates the scarcity of water in surface and underground resources. Agricultural drought occurs when the rainfall and soil moisture are inadequate to meet the water requirements of crops. The categorization of drought is as follows: meteorological drought, rainfall received over an area is less than 75% of its long term average value. Moderate drought, rainfall deficit is 26 to 50% of the normal rainfall. Severe drought, rainfall deficit exceeds 50% of the normal rain. If the area affected by drought is more than 20% of the entire area of the country, then it is declared as a drought year for the country. The meteorological drought may also issue alerts about the hydrological conditions prevailing, which can have a direct impact on various related aspects like non-agricultural production, including hydroelectric power generation and drinking water supply. Coupled with a robust monitoring system, the mechanism put in place for rainfall prediction and drought early warning brings out total solutions for drought management. The early warning systems use methodological improvements such as use of moderate spatial resolution data, remote sensing for disaggregated level assessment, use of multiple indices like aridity index, agromet parameters for drought assessment, augmentation of ground databases, achieving synergy between ground observations and satellite based interpretation, providing user friendly information, enhanced frequency of information in the form of FWB, farmer weather bulletins, etc. Summary: disasters cause a havoc, usually wrecking the normal life, but with the help of early warning systems EWS, the magnitude of loss can be effectively mitigated. Early warning systems differ based on the various types of disasters. Simply put, early warning system is an warning / alert before the happening of disasters. Quite a number of government and other agencies are involved in issuing disaster alerts based on the information from deployment of technical know-how ranging from satellite operations to radars, remote sensing equipment, etc. Floods, cyclones, earthquakes, landslides, droughts are some of the common disasters which occur frequently, but rarely a tsunami occurs. The success of any EWS is dependent on its effective communication to administrators and users with real time, reliable and timely information to enable prompt interventions.